All right, let's talk about something that's happening all around you and even inside you right this second. It's a hidden chemical process that, honestly, is absolutely essential for our existence. It works silently in our bodies, in our food, and our medicine, all to maintain this perfect, delicate balance. So yeah, let's dive in.
So to really get why this chemical hero is so important, we first have to understand the problem it's constantly solving. And the thing is, our world, and especially our bodies, are always teetering on this chemical knife's edge, a super precise balance that we measure with something called pH.
I mean, think about it. You go to the gym, you have a really tough workout, and your muscles start producing lactic acid. That's acid, right? But your blood doesn't just suddenly become dangerously acidic. Nope, it just hangs out steady at an incredibly precise pH of 7.4. How on earth is that even possible? And this isn't just happening inside of us, it's in the food industry too. You know, the artificial sweetener aspartame in your soft drink, it would literally fall apart if the pH wasn't just right. Or the fresh, tangy flavor of your favorite jam, that's also locked in by controlling the pH. So what is the secret?
Well, there is a single, kind of elegant answer to all of these puzzles. There's a chemical guardian angel, if you will, that stands watch, preventing any of these crazy swings in pH. So let's finally meet the unsung hero of our story. That's it, a buffer system. This is the amazing chemical machinery that's responsible for keeping everything stable, from the cells in your body to the jam in your fridge.
So what is it exactly? Well, you can think of a buffer as a solution that's basically a chemical shock absorber. You can add a little bit of acid or a little bit of base, and the buffer just takes the hit, fighting back to keep the overall pH almost perfectly constant.
And you know, this quote from our source material really just nails it, sums it up perfectly. Buffers are specialists with one job and one job only, to maintain the status quo and keep that pH locked in. Okay, so how in the world does it actually pull this amazing feat off? Well, the magic here isn't in one single chemical, but in a partnership. Seriously, think of it like a perfectly coordinated chemical tag team.
See, every single buffer system has two key players that are chemically related. First up, you've got a weak acid. Its entire job is to jump in and neutralize any base that comes along. And then you have its partner, the conjugate base, and its specialty is taking out any incoming acids. They work together, but each one handles a totally different kind of threat.
Let's watch this in action. Okay, imagine a strong base gets into the solution. Immediately, the weak acid part of our team springs into action. It reacts with those base ions, basically gobbling them up and turning them into harmless water. Just like that, the threat is gone and the pH barely even budges.
Okay, but what happens if an acid is a threat? Well, that's when the other partner, the conjugate base, tags in. It grabs those incoming acid ions, takes them right out of circulation, and turns them back into the weak acid component of the buffer. So again, the pH stays stable. It's just this beautiful, totally self-regulating system.
Now, this chemical tag team is not just some weird thing you find in a lab. It is everywhere, performing this incredible balancing act in countless processes you probably never even thought about. So let's go back to our first questions and see this hero in action out in the wild.
So remember that lactic acid from your workout? Yep, that's handled by the hydrogen carbonate buffer in your blood. The reason your jam tastes the same every time? You can thank a citrate buffer for that. The stability of aspartame, the fact that some medicines don't upset your stomach, and even the basic functioning of every single cell in your body. All of it depends on these very specific buffer systems holding the line.
But here's the thing. As powerful as these buffers are, they're not invincible. Every single buffer system has a breaking point. There's a limit to how many punches it can take before it just gets completely overwhelmed.
And that limit, that's what we call its buffering capacity. It's basically a measure of just how much acid or base a buffer can soak up before it fails, and the pH starts to change dramatically.
So what makes one buffer stronger than another? Well, it all comes down to concentration. A buffer with a high concentration of its tag team partners is like a team with a really deep bench. It can handle a lot of threats. But a buffer with a low concentration, it's got a small team and it gets overwhelmed way more easily.
And this chart, wow, it just shows you the difference in a really stark way. Look, when you add the same amount of acid to both, the high-capacity buffer, it barely even registers a change. But the low-capacity buffer, the pH absolutely plummets. Its defenses are just completely overrun.
So here's a big takeaway. An effective buffer is really a numbers game.
You have to have a large reservoir of both the weak acid and its conjugate base ready and waiting to neutralize whatever gets thrown at them. It's not just about having the right players on the team, it's about having enough of them.
These systems are the silent, absolutely essential stabilizers in our world, from inside our own cells to massive industrial processes. And that kind of leaves us with one final, pretty critical question. In a world that's facing huge chemical shifts, like ocean acidification, what happens when nature's most important buffers get pushed past their breaking point? That's definitely something to think about. Thanks for joining me on this one.